Hi, I am Tapan Chakraborty. Welcome to my channel Fly with Tapan. Do you know which is the highest mountain in the world? It is Mount Everest. Its height is 29,032 feet. To survive at this height, all mountaineers carry heavy clothing, oxygen cylinder, oxygen mask, and many other gear. Aircraft fly above 30,000 feet height, which is more than the height of Mount Everest. But passengers enjoy a coffee or a burger at this height while wearing a t-shirt during an air journey. How it is possible? What support does aircraft cabin provide us so that we can stay easily and can enjoy our journey? Today we will look into it. We are most comfortable with the atmospheric pressure at ground level, but the performance of aircraft become better and better at a higher altitude, especially above 30,000 feet. Here the air is very thin, so the air resistance is very less, therefore higher fuel efficiency of aircraft. It is also generally above the turbulence cloud, and it is a bird-free zone. But when humans start moving up, it creates problem. The atmospheric pressure keeps dropping as we move at a higher altitude. It affects our body. There will be swelling in our body, eardrums will pop, and there may be a joint pain. Another problem is due to low pressure. All air molecules, including oxygen, will separate from each other. When we inhale this air for our breathing, the oxygen goes inside will not be sufficient. The person suffering from this problem will have a vomiting sensation, vision blur, and he won't be able to do the simple tasks such as putting his own oxygen mask or even remembering his name. He will become unconscious and eventually may die. To overcome this problem, each passenger can be provided with an oxygen mask, hose, and hose will be connected to oxygen cylinder. But this arrangement is not practicable for so many passengers. The alternate easy way is to pressurize the cabin so that the oxygen molecules come close to each other again and become as dense as they are on ground. So the aircraft cabin needs to be pressurized. The jet engine has a series of compressor blades in the front. It compresses the air, then it mixes with the fuel, then the mixture is sent for combustion. Before mixing up with fuel, a certain amount of compressed air is bleed out and sent to aircraft cabin through a pipe. Of course, it will reduce the efficiency of engine a little bit, but alternate options like carrying a separate compressor are going to be more expensive and bulky. As this air is coming from engine, it is hot and dry, so in between there is a condenser to cool the air, and it is also humidated. The compressed air which are coming out from engine may not be at a uniform rate as engine RPM varies, so there is a regulator in between to maintain uniform input pressure in the cabin. So this way the cabin is pressurized and all air molecules including oxygen again comes close to each other. Now passenger can breathe normally in this air. But here is a problem. As the outside pressure will keep on decreasing with the altitude, there will be a more pressure inside the cabin. As the surface area of the cabin is very large, this differential pressure will create enormous force. This is a structural challenge while manufacturing the aircraft. The cabin is made strong enough so that it can withstand the differential pressure. There is a safety valve at the rear of the cabin. In case there is an excess pressure due to some fault, the valve will open and allow the excess pressure to escape. When the aircraft flies at a height of 30,000 feet, the outside atmospheric pressure will be 4.4 psi. Psi means pound per square inch. If inside the cabin, the sea level pressure is maintained, which is 14.7 psi, the differential pressure inside and outside of the cabin will be 10.3 psi, which is huge. To reduce the differential pressure, the cabin is not kept at ground level, rather it maintains the pressure equivalent to 8,000 feet height, which is 10.9 psi. Now the differential pressure is 6.5. Now it is considerably lowered. So less force on the surface of the cabin contributes more flight safety. And human beings do not face any problem up to 8,000 feet or even up to 10,000 feet equivalent pressure. This is how aircraft cabin provide a very comfortable atmosphere for their passengers. What happens if pressurization fails? Say one window glass is shattered. Straightaway cabin will be exposed to outside atmosphere. Pressurization will go up, air condition will go up, oxygen will not be sufficient for breathing, clouds and moisture will enter. Due to engine sound, passenger won't be able to hear each other. In one word, extreme emergency. The pilot will put on his oxygen mask first. Passenger mask automatically comes down, or this action can be initiated by the pilot from the cockpit. All passengers must wear mask correctly and promptly. Without oxygen, he may become unconscious within a minute or even within a few seconds, depending upon at what altitude the aircraft is flying. That's why it is very important to listen the safety instructions given by the crew before flight. Passenger oxygen is not supplied from a cylinder, but from an oxygen generator, which by chemical reaction produce the oxygen. It can supply oxygen for 12 minutes. By this time, the pilot will start an emergency descent and bring the aircraft to a denser air, where passenger can breathe from atmospheric air. Now the next action of the pilot would be to make an emergency landing to the nearest suitable runway. If you feel the information I shared with you is valuable and interesting, then please consider subscribing to my channel.